Thank you, everyone. And so some of you already have seen Shapelets in action, or we had some close contact in the past. Some of you guys are brand new, so very much welcome for joining us today. We like to call it a 360 platform for data scientists, in which we try to create an environment whereby data scientists can access the data quickly. They can publish their results throughout their organizations. They can create amazing visualizations without having to leave their environment. And most importantly, what we try to focus on is improving the workflow between data scientists and the rest of the businesses, because we live in a data-centric era, and we really need to get the right tools at the right places in order to get our job done in the best possible way. So, first and foremost, what do we mean by a 360 platform? Well, when we started Shapelets, we tried to envision what would be the tools that we would love to have had in the past, and we, for whatever reason, they didn't exist, or we had to create them, or perhaps partially creating them in a different environment. So when we started Shapelets, we thought, we put together a shopping list of things that we want to have we would like to have in our platform. So first and foremost, our platform has to be connectable with almost any data source available in your environment. It has to be open. It has to play extremely well with the rest of the ecosystems that you might create in your organization, or you create on behalf of other organizations. It has to be scalable, and it has to be built in with certain algorithms that make them special. Especially, we thought that our starting point would be time series analysis, because it's an area that we know intimately from our past experiences, and therefore we have created an analytics section of our own product that brings algorithms as well as data management. And all in all, this is basically what we call the Shapelets architecture, which has 4 different components, out of which, when you join them together, you get a 360 perspective of all the different activities that a data scientist might be able to do. So the core component of our system is all to do with storage, data management, and computing. Today, we're going to talk about data ingress and why does it work, or how does it work in Shapelets, and what are the benefits that it comes with. But obviously, it's not to do just about storage and computing, because that really represents a very important part of the data scientist pipeline. But nevertheless, there are other parts which are important. Another one will be what we call Shapelets Flow, which is our Python API that allows us to connect with NumPy, with Pandas, with Keras, with TensorFlow, share data, share models, and really create unique algorithms for your unique business needs. And this flow, this library that we call Shapeless Flow, has a component which is extremely important for us, which is to do with data apps. By data apps, which we're going to see today, we let the data scientists to create directly from Python without having to deal with developer teams or the provisioning team in your organization, or directly from the fingertips. They can create HTML applications from Python that allows the data scientists to create visual representations of their work in such a way that can communicate better with their business stakeholders, or to just basically provide proof of progress, proof of tracking of their work they do in your organizations. This is extremely important, and what we found out is that this concept of data apps allows the data science to speed up tremendously their development process. Obviously, all these different components, we like to join them in a single hub, single platform, which is powered by algorithms that are basically created in collaboration with a few organizations. Among them, quite a few universities. We have very close links and relationships. So we work together with data scientists in those environments to bring really efficient implementations of key algorithms in certain areas to back you up in your analytical workflows. So all in all, that's what we call Shapelets. As I said, a 360 platform that tries to have an answer for all the different needs that data scientists might have throughout the life cycle of a data science operation.
So good afternoon, everybody. Thank you, Fatima, for the introduction, and Justo also. I am very happy to be joining this session where Justo and me will be showcasing some of the capabilities of our platform. Before I start, let me go back just one slide, if I may. Yeah, okay. Yeah, just to give you a little bit of context, I will be talking about some of the problems that I have personally experienced, or that I know some of my colleagues, data scientists, have experienced when dealing with data visualization. So not just when developing or creating more or less complex visualizations, but also when it comes to sharing those visualizations with the business. And many times we see ourselves in this trade-off between, building a very high quality professional visualization that usually takes a lot of time, or going for something more simple, but that will bring value to the business faster. And it's a trade-off that we usually have to deal with. And so talking about these issues that we usually face when dealing with visualizations, I have listed here 6 pains that we data scientists typically have to deal with. So the first one is that us data scientists, we're not designers, we're not web developers. So for us, it's actually hard to build professional visualizations, to design visualization layouts, or build web applications. Also, when we do our work in large organizations, like I said, usually there's, I think Justo mentioned it, there is typically a team that takes care of building the visualization. So from the moment that you obtain your insights and you want to externalize and you want to make them visible, it takes some time until they become actually visible, because those visualizations need to be developed by some other people. Also, if you are familiar with web technologies, you might know Vega is for example a very powerful visualization library, but it's not easy to use it in Python. Whereas other libraries that are extremely common to data scientists and Python developers, like Matplotlib, are not that powerful. They don't allow you to create interactive visualizations, for instance, and well, they have certain limitations. Also, when you are dealing with very very big time series, or large amounts of data, and when you're trying to visualize them using standard technologies in a web browser, this is probably going to make your browser freeze, and it's going to create a lot of frustration. So You don't want to use standard tools to visualize large amounts of data. Also, when you have already built your insights and arrived to some interesting insights, you want to share them, or you want to maybe have a discussion about them, or a dialogue with the business about them. And this is typically hard to do with current tools. I mean, there are solutions that are arising to deal with this, but they are not so popular, and the learning curve sometimes it's not easy. And finally, the sixth point that I would like to mention is that our work is sometimes very hard to document, to trace. Maybe you create a visualization, but then you change it, and then you don't know what changes have been applied to it. And these are some problems that are extremely common in the daily work of a data scientist that is trying to build visualization. I will show you how we can very easily create extremely powerful visualizations. So this is the data scientist environment. Pie chart. Here is where the magic happens. And we data scientists spend a lot of time here, right? What I'm going to show now is how we can, with very few lines of code, create some very powerful visualizations. We will start with a hello world example, and I'm going to run this, 7 lines of code here, and we're going to navigate to the browser very quickly. Okay. Sorry, because I'm having to change screens, but okay. So we are this is the homepage of Shapelets platform, and I just ran the data app. It just appears in our list of data apps, and we can access it, and we're going to see this hello world example. Okay, just to give you a quick overview of the platform, we have different sections, so we can navigate through sets of collections, dashboards. Today we will be talking about data apps, but we have also some options to decide how we want to share both the data collections and the data apps. So I'm going to, in order to introduce the next example, I'm going to navigate to one of the collections. This is the NNOC Open Data. This is an open data set that contains about 100 time series corresponding to the energy consumption of several buildings in the United States. So I can access one of these, and you can see the data that we have for this sequence, and also some metadata that is stored together with this time series. And we're storing things like, okay, so what industry does this building belong to, sub-industry, what are the square feet of this building, etc. So we can store a bunch of data, and we can navigate through the data already from here. Okay, but what I want to do is build a data app that will allow us to quickly visualize all this data and navigate through it very easily. So I'm going to run another data app. I'm not going to switch screens just to make it easy, but I will create a data app that has less than 35 lines of code. So if I navigate to the data apps, it's here. I can access it. And basically what we see here are 2 filtering components and 4 time series that I have randomly selected from all the big list of 100 time series. And what I can do here is I can apply filters to some of the data that we have here. So for instance, let's imagine I'm just interested in those series whose data quality index is between 30 and 75. And also I can apply a filter based on the industry. And as you see, some of the sequences that belong to, actually I have filtered everything, but we can switch to another section where we're going to have at least one sequence. So I can, from here, directly select and see the amount of data that I have for a particular industry, or I can see this histogram that shows me the amount of series that I have for a specific range of data quality index. And this is extremely powerful, because I can do this with a larger amount of time series, and this will allow me to learn very quickly how this data is distributed, and what are the most relevant classes, and so on and so forth. So to continue, let me run another data app. We're going to add just barely 10 more lines of code, and we will build a visualization in order to explore another data set. In this case, is a data set that corresponds to some weather data that was collected in near Lake Michigan in Chicago, Illinois. And this data app is a little bit different from the previous ones, because it has some tabs. Okay, this allows us to arrange the data very nicely. So for example, we could have like the sequences corresponding to the different streets or locations in different tabs, and that's what I actually have done here. Okay, so for example, this is the data corresponding to Oak Street, and I have temperature, barometric pressure, humidity, and so on. And I can actually navigate through them. I can actually zoom in and do some quick navigation over the data. But as you see here, I'm just navigating through one of the time series. But I have created this second tab in a special way, where all the sequences are in what we call a temporal context, which is basically when we are navigating in one of the time series, we're basically navigating through all of them simultaneously. So now if I zoom in here, I will be zooming in all of them, and I can check each of them individually for a specific moment in time, and I can do this seamlessly from a web browser in my local computer, which is something extremely hard to do with current technologies available. And don't forget that I have done this with less than 100 lines of code, by myself, basically. So yeah, this is actually very, very powerful. We can also create tabs that have other components, other widgets. In this case, if I'm only interested in visualizing one of the time series, for example, maximum wind speed, or one that looks a little bit more nicer, like wet bulb temperature, I can also do it from here. And I can do some other nice things, like, for example, I don't know, changing the line type. Let me make this full screen. I can change the line type here. For example, to get a dotted line, and I can also, maybe make it a little bit wider, to make sure I can see it nicely, and maybe change the color, and I'm doing this very easily and very quickly. Just to show a final example, I have created here a multi-line chart, which allows me to compare various time series, seeing them all in the same line chart. And here I can do some pretty cool things. I can move some of the lanes up and down, and arrange them as I want. For example, I have these two time series at the bottom. Imagine I want to see them together in the same lane. I can just do this and accept, and now I'm seeing them. The green one is attached to the left axis, the red one is attached to the right axis, and I have not lost a single piece of functionality. I can still play around with these, and I think this is very powerful. If I zoom in, you can see how I am getting more detail about the time series. And well, this is just a little example of what we can do with some powerful visualizations in Shapelets. I have one last example, just to show you that we're not limited to line charts, but we can also create more advanced visualizations. Donut charts, radar charts, pie charts, polar charts, and I can have those charts preloaded, or I can run computations based on, for example, user inputs, and compute those charts based on some input that I have given to it during an interaction with the data app. So this is also very nice. And we can also create more advanced plots like scatter plots, for instance. Okay, so this is a little bit of what I wanted to share about some of the things you can do with visualizations in our platform. So just to wrap up my section here, why is Shapelets interesting? Why is Shapelets so powerful? Well, as you can see, as you have just seen, we have a very easy to use Python API that enables us data scientists, without the need of, IT services, create professional visualizations and do it in less than 50 lines of code. The visualizations that we create allows us to navigate very quickly over time series and zoom in and scroll or move around. And we can do this directly on raw data, so we don't need to compress the data or remove data points or anything like that. So that's great. Like I said, we can build and share those interactive data apps very quickly and easily. We have a user management system, so I can decide who can create a data app, who can modify it, who can access it, and I can also export all these visualizations to PDF. And that's all from my part. Justo, you can
I think
on from here.
Before you go, there was one question which is quite related to what you were describing, which is to do with how can you create different apps like street names and the like. So before I take over, perhaps it could be a good idea to answer that question right now. And if you were to focus on the code that we had that you had on the screen, perhaps we can go very quickly over the code, so we can actually give everybody a sense of how it's like to program in Python one of these data apps.
Yeah, absolutely. So this is actually the code that corresponds to the data app that has multiple tabs. What we want to do here is to create tabs flow panel and place it in the data app. And then we can add multiple tabs to this tabs flow panel. So we create these tabs as vertical flow panels, and we place them in our tabs flow panel. We give them a name, okay? And then in each of these tab elements, we can, place line charts or place selectors. There's a selector here, so we can add all these different components directly to the tabs. So it's just as easy as this.
Yeah, I mean, the API is pretty straightforward, and it always tries to hide as much as possible from the complexities of all the paneling and layout, composition, and the like. But really, a tab is nothing more than a container that has a title that we understand that you are intending to create a tab on the screen through the app, through the API, and then basically the rest of the logic takes over. So you're not really in control of what is the final look and feel of the application, but what we do is basically we are very much like intention oriented in this API. So my intention is to create a bunch of tabs. So let's do that. Let's not worry about details and the like, and that allows you to go really real quick. So, for example, could you add right now, for Adrian, a new tab? Just call it Pepe. And rerun the application again.
Yeah, let's do it.
So you might need to change the tab number. Yeah, that's it.
Here, and yeah, this is 3. So I'm gonna switch now to the browser. Let me move back to the data app. So
there you are. So you have an empty tab. Yeah. But the good thing is that this is how long does it take to interactively create an application. So you are basically writing code, run it through the system, and then immediately you get your visualization up and running. So it's tons of fun to create these apps, because it's a very self-learning, self-discovery type of process that you don't need the documentation, which is great, and you can very, very quickly get up to speed with this. It's a very nice tool. But as you can see in this picture, modeling and data visualization is just a small section of the entire cake. We as data scientists usually spend more time than not on data mining, data cleansing, data exploration, creating new features for the models to run properly, and that goes to the point that almost about half of the activities that we do with any in a data-centric workflow, it takes about 50% of all the activities, more or less. I would even suggest that even more. But if you see it from the perspective of IT budget allocation, it takes in about 70% of all the IT cost in medium to large size organizations to actually perform these tasks, because you need to allocate cluster resources, databases, infrastructure, personnel that looks after the ingestion process, the quality process, and so forth. So it's a really, really important part of the entire pipeline that we are currently running. So whether the changes have to do with your department directly or your clients, if you're working, for example, in a consultancy, and it has anything to do with the size of the data sets on disks, the agility to access the data, the preparation and that is required for the data to be consumed by a data scientist or a team of data scientists. I think really we've been really scratching our head to see how can we make this thing much better. And the response is to this is a new data format that we have introduced in Shapelets, which I'll mention briefly, that we believe allows you to reduce the total cost of ownership of your data storage solution by reducing the amount of data on disk about 80%. I'll show you an example in a second. This has led us to fantastic streaming capabilities where we can make data available in a sub-second way to your data scientists. So you can your algorithms can consume the streaming data with extremely low latency. And obviously, we have increased the abilities or algorithms that we have in terms of data cleansing and alignment, of especially temporal alignment for time series. And we have created new distributed structures that allows you to do things like feature engineering. Like could be, for example, countings, it could be summaries, it could be histograms, it could be all sort of online distributions to do it alongside your streaming capabilities. What it makes our data handling so special? Well, we've been scratching our head in terms of what we do with time on our systems. And what you have on the screen is a typical columnar representation of a time series on any system. So you have one column representing the time and another column for the simplicity with some measures. Some of them might be missing, some of them might be complete, but all in all, a sequence of data might be represented this way. And this could be as small as a few hundred points or as large as a few billion points on a very same sequence. So when we started working on this, what we did is like, well, how we can actually make this thing better? So the first thing that we did was we started concentrated on the time axis that allow us to index the data. And after a lot of research and development, we actually discovered that we don't need it. We can actually use a proxy for that information, so we don't really need to store time anymore in the system. That already presents itself with a 50% data reduction, not only on disk, but also in network traffic, also in memory for your algorithms and so forth. And we can recreate straight away that time information if need be with a very extremely fast speed. So that's the first thing that we did. And then what we did is to start thinking about, well, what we should be doing now is to start partitioning this data set and then start coalescing data that is close in time together, which usually allow us to get a much a better degree of compressibility of the data, because the numbers usually within time periods are usually more or less, they don't change that dramatically. And then we also give us an opportunity of removing the space that missing points are actually occupying in memory on disk, and just use a bitmap index technology that allows us to basically account for those points that disappear. All in all, basically, we're surprised that when we put this thing in place, our existing data sets went down about 80% at least on disk, and therefore all the network transfers between the database or the storage system and the working and the algorithms start working extremely fast as well, because there is less data on the wire. All these data structures are cache friendly, so our algorithms run really nicely with CUDA and vectorized extensions. And really, it's been one of fantastic changes that we have introduced in our system. Just to give you an idea, I come from the financial sector, so this is an area that I know pretty well. Say, for example, that you are capturing Bloomberg or Thomson Reuters or any other trading venue. You are basically storing Forex prices for the Euro USD, for example. I mean, this is a particularly busy ticker, and it can basically go quite easily. During working hours, about 600 ticks per day, more or less. And so if you do the numbers with the structure that I was having before, with two different columns, one of them is time, the other one, let's say, is the bid or the ask price of this particular ticker. And then you put that information to disk. It's going to take you about 18 megabytes more or less per day just to store only this particular ticket index in your system. With all data representation, it goes down to 1 megabyte per day. That is an 18 times reduction on disk. This is huge when you start applying this over time, over the course of a year, when you have, let's say, thousands of sensors in your factories, or your measurements from your e-commerce platform, or your customer activities in your website, or it could be basically anything that creates data in real time. The amount of the cost saving that we introduce is tremendous with this system. So whilst these numbers are a little bit, you have to take them with a pinch of salt, as we are working towards having our official benchmarks produced in our website, or initial tests are basically telling us that with this data format we can go up to 1.5 million points per second per CPU core. This is drastically miles away from any other system, commercial or open source, out there. Some of the most popular systems for time series ingestion, they are able to do close to perhaps in the order of thousands, tens of thousands at best, points per second per CPU core, and we are scaling up to 1.5 million. Although I suspect that when we publish the real numbers, this figure is going to be slightly more higher than this. All of this is done through the Python API, which is backed up by a super efficient C++ library that we have created. So we are running natively on your environment, and that basically is what allows us to basically manage the data, manage all these flows that we from sensors in extremely efficient manner. So we will be doing another webinar, a more technical one, just describing this API very soon. And if you are interested in this area, by all means, please come back, and we will be delving into the code. Now, so as a summary from my end, I just wanted to say that the improvements that we have introduced, that we have been so passionate about over the last few months, has gave us an edge in terms of having a specialized data formats for data science, which is really what we want. We have kept our compatibility with systems like Arrow, Parquet, CSV files, you name it. It's not a problem for us to basically get data in and out of the system, so there is no locking factor whatsoever with Shapelets. And obviously, we are putting on top of the table a massive TCO reduction of your cost on either on-premise or on the cloud in terms of storage, with less transfers. The transfers are going to be smaller with less amount of disk in use. And obviously, now you can do far more with less infrastructure in order to support your ingestion rates and keep your system up and running. And this is all for me. So I hope you share my enthusiasm presenting this thing today, because I think we have something which is really interesting for either for your businesses or for your clients. And if you want to know more, we'll be delighted to take questions from you guys, or to schedule sessions at some point to go further with these improvements and innovations that we have created.
Yes, thank you, Justo and Adrian. So let's move to questions. Does anybody have anything you'd like to ask? Any doubts? Because if not, if you let me, I can provide some that I've received. So the first one would be for Justo, please. Just one quick question. If Shapelets if Shapelets removes the time component of data, how does he remember when a point occurred?
Oh, I see. What we have done. Let me see, because I believe I can start my video now. Sorry about that. I couldn't do it before. What we have done is to replace that time information via an index that we have created, which is basically based on bitmap technology. And that really what allows us to do is, in order of one, locate a point value in a specific point in time across the distributed nature of our system. This is kind of cool, because then what it means is that we don't need auxiliary data structures like auxiliary database indices or anything like that. We just basically load this index, which is really small. It's a compressed bitmap index, and that resolves all that location and questions that we might have in terms of when a point is present and at what point did it happen.
Thank you, Justo. I have another one. Oh, there's one question in the chat. Any comparison to other tools such as Streamlit, Plotly, Dash Panel?
There are a few, and I think this is perhaps a question for both Adrian and myself. Alanza from the data handling perspective, there are fantastic tools out there, like could be from InfluxDB, all the Tiger DB family, and so forth. But the thing is, what they are is just databases. They are not integrated. They are not integrated with your analytical workflows. They are not integrated with your security systems. They are not integrated with all the web apps infrastructure. And I think this is one of the key components that you will see that when working with Shapelets allows you to get that sense of integration where all your workflows, you can actually run them. And in those areas in which Shapelets might actually be not the best solution for your problem, because it's completely open in their algorithms, in the libraries, and the data formats that it uses, it's actually trivial to use any other system out there. And I think that really speaks quite highly in terms of honesty, in terms of providing an honest view in terms of our platform and our platform capabilities.
Thank you, Justo. I have another one. I think this is for Adrian. Can I visualize data from a Parquet file?
Yes. So I think actually Justo mentioned that we are compatible with several file formats. So as long as we can get the data from the file and ingest it, we can create all sorts of visualizations with it.
Perfect.
Also, I was going to say, just adding to the previous question, because I've also asked myself, this about how this solution compares to things like Streamlit. I challenge you to try to create a visualization of 500,000 points, and you basically cannot do it without your browser freezing, and plus you will not be able to navigate through it. You would basically get a static visualization. So that's what most of the tools that are out there allow you to do today.
Thank you. I have one more question about visualization. Can I share that project with third parties, or only I have access to this dashboard?
Yeah, so there is this user management system that allows you to create different users. And so when you connect to the server, you do it using your credentials. And then with that credentials, you may or may not have permissions to create visualizations, modify them, or share them, basically.
May I say we also have in our roadmap an item that we've been delaying because obviously there were quite a few things to do in the meantime. But we already built one prototype, which is to do with Office integration. What it means is that all these visualizations that you have on the screen, you can actually embed it as live visualizations within, let's say, a PowerPoint presentation. So each time that you run your PowerPoint presentation, the algorithms are running the backend, and then a fresh view on the results are actually present directly in that presentation, which is really useful when you have like things like monthly reports, things like could be a weekly analysis of customer behavior in your website, or how my factory's been doing over the last 24 hours. So you can actually build yourself a data app and then incorporate all these visualizations into a PowerPoint presentation, and then basically just do it once, and then you have reduced the amount of weekly workload tremendously just by using that feature. This is something that we will be launching by the end of the year, but if you are interested in this feature, we can actually tell you more or even show you the prototype running at some point.
Thank you, Justo. I also have one more question. What is the licensing model for Shapelets?
Do you want to answer that, Adrian, or shall I? I'll do it. The license model is really simple. It's Shapelets comes as a built-in box that you can run. I mean by that a closed distribution. So it's very simple to install in a Kubernetes environment, whether it's in premise, whether it's in the cloud. And then the licensing model is based on the amount of resources the system has. There is no charge model for users, so you can have 1,000 users or have like 3 users, doesn't really matter. And it doesn't charge you for how much data is flowing through the system. It's just simply how many resources are you powering Shapelets with, and it's a very transparent model that we can share with you guys anytime.
Thank you, Justo, and thank you, Adrian, and thank you everyone for joining. I'm gonna close this session now, but if you have any further questions, any further queries, you can always contact us on our website, emails, and thank you all for your interest and hope to see you soon.